Welcome, welcome. This is Mr. Jarvis from IED, Introduction to Engineering Design. And activity 1.7.4, auxiliary views, requires that we do and create an auxiliary view by hand or with sketching. When I say sketching, of course I mean that we need to sketch using some sort of straight edge and a pencil, typically with a pencil, so we have good line quality is really what we're looking for. So if you look at the first activity, and that's what I want to walk through with you today, is this one. We have this really kind of a odd shape, as you can see. This is an odd shaped, and they've given us the front view of it here, right? The front view. They've given us the front top view. Now realize we can see this diagonal plane right here, this inclined plane, but it's what they call foreshortened in the top. And on this front view, I can see the edge, which actually is the right length, but I can't see the entire inclined plane. In this activity, they want you to draw what the right side view is and then do the auxiliary view for it. So we're going to start out by doing a simple numbering technique for each point on the actual inclined plane. So if I number this 1, this 2, 3, 4, 5, and 6. Those are the 6 parts of my inclined plane. So if I were looking in the top view, I could say, okay, this is 2, because that's the bottom here. This would be 3, 4, 5, 6, and number 1. Now, interesting enough, if you project them down, this is going to be 6, and behind it is number 1. This one's number 5. That one's the number 4. And then, of course, 3 here with 2 behind it. The number 2 is going to be behind it. So if we start out by doing the right side view, we're going to use our projection lines. And I love that they give you the grids to follow because it makes it that much easier. So I'm going to use my projection line here. I'm trying to get it, I think, somewhat close to the grid lines, but I'm lining it up so it lines up. Remember, all the heights in the front are going to be the same as the height on the side. It doesn't change height. All the heights are there. So I use my projection lines there. The next step is to number it. So let's say this is going to be number 1, and this is going to be my number 2, point 1 and point 2. And that would give you this kind of this back line right here from 2 to 1. Once again, I'm going to use the lines on the grid. So there's 2 to 1, and that's the back side. So I need to know how far it is from 2 to 3 and 1 to 6. The nice thing is the top view gives you your depths. 1, 2, 3 and a half, looks like 4 squares. 1, 2, 3, 4, dot. 1, 2, 3, 4, dot. So this ends up being my number 6 on the top and number 3 on the bottom. So I can make a line that goes from 1 to 6 and one that goes from 2 to 3. And kind of like what we did before, 4 and 5 are here, and because I have my depths in the top view, 1, 2, 3, 4, 5, 6, looks like 6 and a half. 1, 2, 3, 4, 5, 6, 6 and a half, that's going to be my number 5. 6 and a half is going to be a number 4. So looking at that, I can play connect the dots. It goes from 4 to 5, goes from 5 to 6, and from 3 to 4. I'm going to clean out my projection lines. If your projection lines are nice and light, you don't even have to bother. You can just leave them on there. They should be pretty light, but so the right side view of this object, all you see is this inclined plane, basically. this part is way out front, like towards me, and this part is going to be set back. But so this becomes what they call foreshortened. It's not the true size and shape. I'm going to do that same process to do my auxiliary view. And the nice thing with the worksheet is they've already projected at 90 degrees or perpendicular to the inclined plane here. So all I got to do is kind of follow those lines, very similar to what we did with the right side view. We're going to just do it here. Inclined plane. Now, sometimes they line up perfectly with the grid lines. I noticed that 5 doesn't quite, so I'm going to try to follow in between the grid lines to be accurate. And I know number 6 doesn't do that either, kind of just below that grid line. So this is the whole length of that inclined plane, true size and shape. As a matter of fact, if we're lining this up, this one becomes my 1, and the other side becomes my 2. Now the depths don't change, meaning the depth of the object didn't change. So whatever depths I've used from my top view are going to remain the same. So there's from 1 to 2. And we said it was 4 squares from 2 to 3. 1, 2, 3, 4. There's my number 3. 1, 2, 3, 4 squares. There's my number 6. So I'm basically creating an auxiliary view of that inclined plane that is going to be the true size and shape of that surface. Whereas you don't see it in the top view, you don't see it in the right side view. Now, we said it was 1, 2, 3, 4, 5, 6 and a half. 1, 2, 3, 4, 5, 6 and a half. That's going to give me my number 5. 2, 3, 4, 5, 6 and a half. This is my number 4. So I set it up. Goes from here to here, and then it's just basically like we did in the right side, connect the dots. I'm going to remove my projection lines so you can see the actual auxiliary view. This is the true size and shape of that inclined plane. What's that mean, true size and shape? Imagine if you could take this object, put some ink on it, on that whole surface, and just pressed it on there. If I just pressed it on there, that would be the actual true size and shape of that entire surface. And that's your auxiliary view for activity 1.7.4, number 1. You will scroll on and do the next page or the next activity. I recommend you use that numbering of each of the corners so that you can really map out what it's supposed to look like. If you have any questions, obviously, you can shoot me an email, and I'll talk to you soon. Good luck.